Now we will discuss about the process parameter in ultrasonic machine. What is the effect of process parameter on final quality? And what are the different parameters? First one is the amplitude of vibration. Means what? It is a travel distance. If we consider the starting point is 0 and how much the tool can vibrate, or we can say maximum length. As we have discussed the two type of transducer, one is the piezoelectric and second is the magnostatic transducer. In both the case, what we are doing, we are generating the oscillation with the help of the electric current and magnetic field. So that is the oscillation, length of the oscillation, that is the 15 to 50 micron. Means what? Minimum we can achieve the accuracy up to 15 micron and maximum 50 micron. Now second one is the fixed frequency of the vibration. Its range is 19 kilohertz to 25 kilohertz. Means what? The tool can vibrate up to the maximum 25 kilohertz. If we increase the vibration, then what will happen? The energy which is basically used to remove the workpiece material, that will increase as we are increasing the frequency of the vibration. The next is the feed force. If we increase the traveling speed, it means what? Small amount of abrasive particle will took part in the actual cutting process. As we are increasing the frequency, definitely material removal will increase. If we are increasing the amplitude, it will reduce the accuracy. But if we increase the feed rate of the tool, it will decrease the MRR. Now next is the feed pressure. If we increase the feed pressure between the tool and workpiece, basically in between that we have abrasive slurry, that is a mixture of the abrasive and water. As we are increasing the pressure on the abrasive particle, it will ultimately increase the pressure on the workpiece material. Those are connected with the abrasive. Suppose we have only one abrasive particle between tool and workpiece. As we are applying the pressure on the tool, it will transfer to the abrasive particle and ultimately it will transfer to the workpiece. So it is increasing manner if we increase the feed rate. Now next is abrasive size. As abrasive size increases, it will increase the MRR, but at the same time it will reduce the surface quality. So we cannot use the larger abrasive particle during the machining process. Then abrasive material, as we have discussed 2 to 3 times, we have different type of abrasive material: aluminum oxide, silicon carbide, boron carbide, silicon carbide, then diamond dust. All are having its specific strength. Now next is the flow strength of the work material, then flow strength of the tool material. Means what? Machining process is also depend upon the material property of that work material. If the material is very hard, then we have to use the harder abrasive particle, as well as the more frequency and more pressure. In that case, here we are using the soft tool. Basically, here we are using the soft tool. Then the contact area of the tool, volume concentration of the abrasive in water slurry. And next is tool tool is also very important component. We will discuss how to design the tool, because main role we have discussed the two part basically. One is the transducer and second is the tool. And abrasive are the common, but the technologies depend upon the transducer and tool. In tool we have a material of the tool. It is also very important. Shape of the tool, amplitude of the vibration, frequency of the vibration, and strength developed in the tool. The next is the work material. Work material, material property, impact strength, surface fatigue strength. Then slurry. Slurry means what? It's a mixture of the abrasive and liquid. Here we are using abrasive with a different hardness, size, shape, quantity of abrasive flow. All the these parameters are having the impact on the final quality. Liquid, its chemical property, viscosity and flow rate, pressure and density. So these are the all the variables, those are having the impact on the output. Now next is process capabilities. It can work, it can machine workpiece or any material having a hardness more than 40 HRC to 60 HRC. Like we have a very harder material like carbide, ceramic. Ceramic is very brittle metal, very brittle metal with zero ductility, tungsten glass. It cannot be machined by the conventional method. So ultrasonic machine is basically we can say it is used for the brittle material only. The tolerance range from 7 micron to 25 micron. We can generate the hole up to 76 micron with the depth of 51 mm. But suppose we want to increase the depth of cut, so we can achieve up to the 150 mm deep hole by attaching some special flushing technique. We will discuss on two. That is a linear material removal rate 0.025 to 25 mm per minute, and surface finish 25 micron to 75 micron. Next we will discuss the application of the ultrasonic machine. Machining of cavity in electrically non-conductive ceramic as well as the conductive material, used to machine a fragile component in which otherwise the scrap rate is high, used for multiple step processing for ferrochrome silver nitride turbine blades, used for machining hard brittle metallic alloys, semiconductor glasses, ceramics, carbide, used for machining round, square, irregular shape. Even we can use for this surface impression. Ultrasonic machining can perform the machining operation like drilling, grinding, milling operation on all the materials which can be treated suitably with the abrasive. Means by using only single machine you can perform the number of operation. But the condition is what? The material is suitable with the abrasive particle. Ultrasonic machining has been used for the piercing of dies and for parting off and blanking operation. USM can be used to cut the industrial diamond. It is also used to grinding the quartz, which is very hard material, glass and ceramic. Here we have advantage and disadvantage. It can be used machine hard, brittle, fragile and non-conductive material. No heat is generated in the work, therefore no significant change in the physical structure of the workpiece. As we are using the slurry and there is no direct contact between the tool and workpiece. So no heat is generated during the machining operation, so no change in the physical structure. Non-metal, because of the force electric conductivity, that cannot be machined by the EDM or ECM, can very well be machined by the ultrasonic machining process. It is a burr-less and distortion-less process. It can be adopted in the conjunction with the other new technologies like EDM. So we can say it can be used for the hybrid machining process. We can combine with the other machining process like EDM, ECM, ECG. I'll last some every technology, or we can say every system has some disadvantage. So low material removal rate compared to the other machining process. It is difficult to drill deep hole as slurry movement is restricted. So in application we have discussed, like suppose we want to increase the depth of cut, so we can use the special flushing technique, but the deep hole is not possible in normal machine. Tool wear rate is high due to the abrasive particle. Tool made from the brass, tungsten carbide, MS or tool steel will wear from the action of the abrasive grit with the ratio that range from the 1:1 to 200:1. In this, we can understand that there is no direct contact between the tool and workpiece, but in between that we have abrasive slurry. Abrasive slurry is also solid particle, so it will wear from both the sides. Basically, it will wear to the tool as well as the workpiece. So as we use the brass, so it will wear out easily. But if we use this tungsten carbide, then it will take some time. Then ultrasonic machining can be used only when the hardness of the work is more than 40 HRC. So for soft material we cannot use ultrasonic machining process. Okay, thank you.